Hello and welcome to today's lesson on calculating speed and velocity. So yesterday we learned about the concepts of speed and velocity and distance and displacement. Today we're going to put them into practice mathematically. So for starters, to calculate speed, we have to know two different things. We have to know one, we have to know distance, and two, we need to know the time that the object was moving. So two things you need to know, two quantities. We need to know distance and we need to know the time it took to travel that distance. Our SI unit, our base unit for speed, important thing for you to remember, is meters per second. We can also be other things. We can use kilometers per hour. We can use miles per hour. We can use squares per day. Any sort of distance measurement and a time measurement. But the base unit, our SI unit, the one we use most of the time, is going to be meters per second, or m/s. If your object covers an equal distance, the same distance in equal amounts of time, so for example, if I cover 2 meters every 1 second, I am moving at a constant speed. So every 1 second I travel 2 meters. Another example would be if a train has a constant speed of 67 meters per second. This train moves 67 meters every 1 second. So that is a little bit of background information, some starting points. And here we go. Average speed is calculated, so we're taking the average speed of an object. We're looking at distance divided by time. So this is the equation that you're going to need, is that speed equals distance divided by time, which is shown down here. In this case, we use a V. V stands for velocity. You can use either. So speed equals distance divided by time, velocity equals distance divided by time. Remember, the only difference between the two is velocity indicates direction, or it can be displacement over time. So in this case, d would be displacement, not distance. Most objects don't move at a constant speed, but change. And this, so you, for example, when you drive to school, your car isn't moving the same speed the entire way because you have stop signs, you have cars, you have slow down, stop lights, you have to turn, you have to park. It's all different speeds. But average speed is the total distance you traveled divided by the total time it takes to travel that distance. So if you were to go from point A to point B the same speed the entire time, how fast would you have to go to get there in the same amount of time? That is average speed. When we're calculating this, we'll do a practice question. Suppose a sleder moves 132 meters in 18 seconds. So I know two things. I know that the sleder moves a distance of 132 meters. I know the time he took to travel that far was 18 seconds. Okay, I can then use these into my speed, because I'm going to calculate speed out. So by putting these into the equation, you can calculate speed. So speed equals distance divided by time. So speed equals 132 meters over 18 seconds, which is shown here as well. And if you divide those two across, you're going to get 7.3 seconds. And notice they stopped at 7.3. That's because I have two significant figures here, and I need two significant figures here. So 7.3 is going to be your answer there. So as this bullet notes, just because this is our average speed doesn't mean this is the speed we went the entire way. You may have started off slow. You may have picked up speed at the end. It may have been moving your fastest when you got to the bottom. So she may not have traveled that speed throughout the whole race. Again, you're slow at the start and faster near the bottom. But if we went one speed the entire time, this is what it would be. So this would be the average. So you can go her route where you're starting slow and ending quick, or you can go this rate for the entire 18 seconds and you'll travel the same distance. When we calculate speed, we calculate average speed, which is the total distance divided by the total time. So average speed, which we mentioned on the last slide, is total distance over total time. But as that last slide mentioned, you may not go the same speed the entire time. In this case, we have what's called an instantaneous speed. And this is your instantaneous speed, is a speed at a given time. For example, if we take a super short time interval, or I guess this speedometer at the top is showing you the instantaneous speed. The speed at this instant in time for this car is going to be approximately 140, and I don't even know what the units are on this. Most likely kilometers per hour. But it's 140 and then whatever the units are. So this would be 140 km per h. Okay? So the smaller the time interval, the more accurate your measurement will be. And so in this case, we're getting an exact accurate. Right now, we're at 140, whatever the unit is. If we can measure speed at an infinitely small time interval, that is our exact instantaneous speed. That's what we're doing with the speedometer, where it's being done for you. And so there's your example there. Everything we calculate in this class will be average speed. We won't mess with instantaneous unless it's at a constant speed, then it would be the same all the way through. For example, a couple practice problems. 1. Metal stakes. We'll call this one number 1. Metal stakes are sometimes placed in a glacier to help measure the glacier's movement. For several days in 1936, Alaska's Black Rapids Glacier surged as swiftly as 89 meters per day down the valley. Find the glacier's velocity in meters per second. And then remember to include direction on our final answer. So in this case, we're doing unit conversion. So we're at 89 meters per day. And I'm trying to get to meters per second. So I know I'm already in meters. I have to get from days to seconds. I know that 1 day is the same as 24 hours. I know that 1 hour is the same as 60 minutes. And I know that 1 minute is the same as 60 seconds. So using this, I can take 89 and divide it by 24 and divide it by 60 and divide it by 60. And I will get an answer that is equal to 1.03 times 10 to the minus third meters per second. Or I could write that as a decimal, which would be 0.00103 meters per second. Okay? And so this is what's going to happen. And then this box over here is just reminding you that when you're required to calculate velocity, you can use the speed equation. You just have to specify direction. So in this case, I want direction here. So this is going to be 0.00103 meters per second down the valley is going to be my direction. Okay, so there's one practice example. We'll do another one here on this slide. I will do the first one with you, and then I'll let you answer the second two, and I'll give you the answers, so make sure you pause the video after we do the first one. So question 1 says, find the velocity in meters per second of a swimmer who swims 110 meters towards the shore in 72 seconds. So things that I know. 1, I'm looking for velocity. I'm looking for V equals. 2, I know that the distance, so they swam 110 meters, so I know distance is 110 meters. And I know that time, it took them 72 seconds. So my equation is velocity equals distance over time. So I can take 110 meters and divide it by 72 seconds. If I plug it into a calculator, I get an answer equal to, I'm going to write it down here, of 1.5778 meters per second. I can go back to my question now. I see that 110 has 2 significant digits because there's no decimal, and 72 also has 2 significant digits. So my answer needs 2. So I'm going to round this to 1.5 meters per second. And I need a direction because it is velocity. So because of this, I need direction. So this is going to be toward the shore. So this will be my answer. For now, I'm going to have you answer questions 2 and 3, and then send your answers to me. Actually, send your answers to me through email, and we will continue this and practice this tomorrow. So number 2 says find the velocity in meters per second of a baseball thrown 38 meters from third base to first base in 1.7 seconds. So you're going to take You're going to solve for the velocity of the baseball and be sure to include direction. And then number 3 says calculate the displacement in meters that a cyclist would travel in 5 hours, 5.00 hours, at an average velocity of 12.0 kilometers per hour to the southwest. Remember to include direction. So be careful on this one. That one, you're looking for a displacement in meters, and my units for speed are kilometers per hour. So be careful on this one. You're going to have to move some things around and manipulate your equation. But give those your best shot, and I will post the answers here shortly. So if you're going to work through those, make sure you pause the video now, and I will give you the answers. So on number 2, you should have come to an answer of 22.35 meters per second, which with 2 significant digits rounds to 22 meters per second. And then on number 3, we should have 60 kilometers, which would be 60, because we're looking for meters, should be 60,000 meters. Ooh, this is towards first base here, and then your displacement is going to be 60,000 meters to the, because it's displacement, I need a direction. So this is going to be 60,000 meters to the southwest. Thank you guys for watching, and I will touch base with you later.